Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we're going to do checkpoint 5.15 coming from 5.3 that talks about the divergence and integral test. And here in this problem they want us to look at the series. It's a p series, 1 over n to the fourth, as n goes from 1 to infinity. And they want us to calculate s sub 5, so that's the fifth partial sum. And then they want us to estimate the error r sub 5. Now we know that just a couple of notes, this is a p series, and we know that the p series converges for n, or for p, sorry. P is equal to 4, that's bigger than 1, so we know that the series converges. And if it converges, then we can kind of bound it with an error, so we can figure out what s sub 5 is equal to, and then help us find the error. And actually it's the remainder that we're looking for. They're calling it an error, so we're not really looking at that as an error. It's more like a bound. That's why it's called r remainder. Okay, so the s sub 5 is going to be just the series up to the fifth partial sum. So we got 1 over 1 to the fourth, plus 1 over 2 to the fourth, plus 1 over 3 to the fourth, plus 1 over 4, plus 1 over 5 to the fourth. Okay, so whatever that is going to equal to. Just to give you a peek at what's happening, or you can use Desmos for this. You can type SUM for sum, and then you got a starting point and an ending point, and then you can figure out what you want to put in here. So in this case we want 1 over n to the fourth power, and this is going to be our nth partial sum. So it's about 1.0835. Let's go with 1.0835. 1.0835. Okay, for us to find the error, there is a theorem or an estimate that they discuss in the textbook that says r sub n is going to be approximately r sub n, and we'll use capital N because we're kind of using the little n to be the variable, and r sub n is going to be some a boundary for this that is going to be less than the integral from n going off all the way to infinity, so it's an improper integral of whatever the series it is you're looking at. So this is 1 over n to the fourth, or we'll use x because we tend to use x for continuous variables and n for discrete variables for our sequences. So if we can figure out what this integral is, then we can have this boundary to say that our sum is equal to this, and our remainder or our error term is going to be whatever this antiderivative is, or this integral, this improper integral. So our task is to solve for this integral, or n in this case is equal to 5 because that's what we're looking for. So n is equal to 5, and then we will integrate this from 5 to infinity. So let's go ahead and do that. X to the fourth dx, and then we know that it's an improper integral, so we need to compute it in the finite space from 5 to b, and then let b go off to infinity. And then I'll write this as x to the negative fourth power just to get it ready for integrating. And then let's integrate. So we got limit as b goes off to infinity. Now the antiderivative of this is we're adding 1 to the power, so that negative 4 plus 1 is negative 3. X to the negative 3 will also divide by negative 3, and then we'll evaluate this from 5 to b, And let's write this out. B goes off to infinity. And then this is going to be negative 1 over 3b cubed. So b to the negative 3 is actually b cubed in the denominator. Minus, and then we have a negative 1 over 3 times 5 cubed. Okay, so this is what we have. And if we take the limit at this point as b goes off to infinity, you have a denominator going to infinity, and this whole thing will go to 0. And what do we have left? We have a negative and a negative, so that's a positive. And then this is 5 to the third. Let's see. 5 cubed is 125, and then we'll multiply that times 3. It's 375. So 1 over 375, which is going to be a really small number. Okay. So if I make this into a reciprocal, I'm going to get 0.002667. So 0.002667. So it looks like if this is our remainder, and if we imagine like n getting larger and larger, we're going to have more zeros here because we will be precise up to 2 decimal places. So we can say that this approximation, this estimate for the partial sum, 1.08 is a good estimate for the whole series that goes off to infinity, at least for 2 decimal places. All right, I hope that helps. Good luck.